Welcome to this OST2 lecture about attestation and the TPM 2.0. Attestation is a process of providing proof that something is true. Rather than trusting blindly, we're looking for evidence that can validate what the system is telling us is true. This, of course, transpires to more than computer systems. This is a process in general for looking for evidence of statements, of properties, of characteristics, and so on. How do we create such proofs in computer systems? We can use a fixed hardware solution where we compute a hash digest at a fixed memory location, which is not a bad idea. I've thought about it in the past. The problem with that approach is that it is indeed fixed, and as our computer systems evolve quite rapidly and we have firmware updates and we have configuration changes where configuration might even grow in size, so the original memory region might not fit, it is better to use software to build such proofs. But then comes the next problem. Okay, we know that software can be tampered with. We know that software-only security is no longer good enough. So how can we go around this problem? Well, with a minimal software base, we can use a hardware security module to generate such evidence with built-in trust, and that is the digital signature. And then we can use the platform configuration registers of the TPM that are tamper-proofed to further increase the guarantees of our evidence. And because TPMs are so widely available nowadays in data centers, in laptops, in IoT devices growing and growing, having attestation using a TPM is something very meaningful and useful. This is what we'll learn in this lecture. Let's assume we have all of the process of attestation figured out. We have the hardware components, we have the software base. Why would we use attestation? What are the applications? When we look at our systems, regardless of its type, we have more or less similar main components. We have some kind of an operating system runtime or bare metal firmware that's running. Then we have system configurations. Then we have the actual end application and the application configuration. And depending on the use, we might even have user data or app data outside the configuration. All of these components are important. And are they in a good state? Have they been modified? Maybe without authorization? What is the actual version of these components? Not just by querying an API and receiving a response, but actually having a signed proof with tamper-proofing built in that can tell us exactly the version with confidence, and we can trust that rather than just going on, okay, I just typed -v on this tool and it gave me a version number, or I just queried an API over HTTPS and yeah, great, I received some version again. This is why we need to establish this sort of trust anchors using attestation on software configuration. And once we have this attested data, we can have a control layer make decisions on a remote system, typically an attestation server or a larger service for lifecycle management of the devices, that can further send comments to our minimal code base in case, for example, we need to wipe the device, we need to revert back to a different version, and so on and so on. The most crucial functionality is, of course, knowing that something is wrong or something is off or something does not match. So having the attested data in first place helps us perform monitoring and cut our response time. And then adding a control layer is something extra that we can build over time. There are different types of attestation. As mentioned, the process can relate not just to computer hardware and software and security. It can be used for documents, it could be used in legal proceedings, it can be used even to verify the length of some wooden component that's used in construction. So when we talk about TPMs and attestation in computers, I have split three types by purpose. First and foremost is the most popular. This is file attestation. File attestation provides us a very intuitive proof that a file we're interested in is in the same state that we expected it to be. And this state is proven by generating a hash digest over the file's content. That hash digest we put into a PCR, and of course it inherits the digest of everything from before that. If it was 0, if this was the first PCR extent, that works too. If there are several iterations, so maybe we parse the file at several stages, or we parse several files together, that's okay too. Once that we have that hash digest calculated and inside the PCR, well, we need a way to perform assigned evidence. And the TPM has a command for this called TPM2Quote. There is more than one way to use PCRs for signed report. However, TPM2Quote is probably the most standard way you can do that using a TPM. Now, to perform the comparison and clearly say, okay, the file is in a good state, this hash digest is exactly what we expected, we naturally need some reference value. Typically, when we talk about attestation, this is called a golden value. Moving further from just files, because this could be anything, this could be the firmware, the config, the user data, quite literally anything, we have the next interesting artifact, and that's the cryptographic key. Performing key attestation is about providing evidence about the origin of the cryptographic key. When we talk about the TPM, this means proving that the TPM key truly originated from a TPM, and more specifically from our TPM. There is a dedicated command for this as well, TPM2Certify. Going further, there is a very interesting use case that I covered some time ago, a command that is rarely used, to be honest, but I personally find value in it. The TPM2GetTime allows us to perform time attestation using the internal timers of the TPM, which I think is great for monitoring purposes. Now that we've looked at the types of attestation and the principles of work for attestation, let's try to define some use cases. One very good use case for attestation that I don't see mentioned very often is the authorization of a new node joining our network. This is especially important when we talk about a company network or a home network. Another very useful use case that also maybe don't have so much publicity about it is generating evidence about the configuration of the system and then being able to deliver update to that configuration in a good manner. So when the change happens, we have a way to verify, okay, did the change malfunction? Was there like a bit flip? Does it really set the proper arguments and bits the way we want it to do it? And of course, this is looking at very low level. We can just say about, did we set the properties to the new values properly and perform hash digest and send a signed report. But this is a very useful scenario for attestation. Another scenario is unlocking the decryption key for the file system only after successful attestation. Only when we know the system is in good state, we will give access to the key required to decrypt the important file system. Attestation is also useful to deliver various secrets. Observability and monitoring is something that I've already mentioned a couple of times. It is probably the primary use of attestation nowadays, where the previous use case that I mentioned are just great practical extension of that, and we move from monitoring to control layer. Together with time for response, I think monitoring and alerts are probably the two most common use case for attestation that we have. We mentioned the gold value when performing attestation, and here is a brief overview of how to do this. The first step is to perform local attestation on the system that we need to monitor in the future. We need to prepare the first report, the first evidence about the artifact that we're interested in, especially true when we talk about file attestation. After that, we will provide the EKPub and EK certificate over the network so the system can be authenticated as genuine. We're really talking to a system with TPM. We indeed have an attestation key that is bound to the EK, so we can trust the signed report. From this moment forward, we have a reference value. We have verified the authenticity of the TPM. So we know we have the capability to generate signed proofs over PCRs. And from there, we have the ability to verify with periodic base the state of the system or the file or the configuration. And their reference implementations like Google's Go Attestation and the IBM ACS. Of course, there are also solutions, some of which open source like Keylime and Linux IMA. And cloud providers have for a long time used attestation. There are different capabilities depending on your cloud vendor. It is also true that attestation is available in Android phones, it is available on MacBooks in different variants, and it doesn't have to be necessarily tied to a TPM, but having a TPM enables you to perform attestation easily. The last component that we need is, of course, a remote machine that performs the attestation service, the service that makes the requests or at least handles the signed report and processes them, verifies the digital signature, stores the PCR values, and computes the comparison. And I would even add, as a bare minimum, at least raises an alert if there's a mismatch. Attestation is not a silver bullet as almost anything in life and in technology. The first design flaw that can happen is when using a child key for signing without it being bound by some restrictions. Usually for when we generate an attestation key under the EK, there are the limitations of TPM 2.0 policy. Then we have also the process of make activate credential where we can further verify the origin of the key. Of course, we can perform TPM2 certify over a child key under the owner hierarchy. Just be aware that having a child TPM key with signing capabilities is not generally sufficient to avoid impersonation. You need to have some way to bound it to the TPM so you know that, okay, this is exactly the machine I'm talking to. Of course, there's value to this simplistic approach. Just be aware of the proper enrollment of the TPM and the machine and having the link between the two. Because if your key gets compromised, then your attestation gets compromised. And having a key bound to the TPM identity, to the EK, makes it a bit more difficult. Now, impersonation can be true on the client side that is being attested, and of course it can be true on the server side. This is also why it is good to have some way for the client to verify the server before sending the evidence, because then we'll be sending a lot of data to an entity, to an endpoint that we actually have not verified. And what I've seen in the field is usually using some kind of a PKI solution, commercial or open source, to help mitigate this issue. Replay attacks, I'm not very worried about. There is, of course, a chance to experience that. The good thing is that TPM 2.0 quote generates its report using a nonce. So we have freshness against these replay attacks, and of course the attestation service has to process that and either confirm or reject an evidence by saying, okay, this evidence is not fresh, please generate a new report. And last but not least, be aware that if you perform attestation in user space, then your attestation agent can be vulnerable to any unauthorized firmware and OS updates. This is not to say that you cannot have an attestation service running in user space. This is only to underline and highlight the fact that if you use attestation from user space, you need to make sure that somehow this process is anchored to the root of trust on the system using OS primitives or using firmware primitives to make sure that it's run only when it's in a good state.